Hey guys, welcome to Teach Me Math. Today we're going to be talking about how to solve a system of linear equations. In my previous video I talked about the three different types of linear equations, and I'm just going to go over them really quickly here. When we have two different lines that are parallel, when we have two lines that are the same, and when we have two different lines that are non-parallel. These two parts were pretty straightforward, I guess, where you have two parallel lines, meaning they have the same slope. And the two non-parallel lines, they obviously would not have the same slope. But the two lines that are the same, it sounds almost philosophical, but it's pretty straightforward, and it's best shown in an example. So if I show, so this is what I'm talking about. If I give you 2x minus 3y is equal to 4, and I say that 4x minus 6y is equal to an 8, at very first glance these look like entirely different linear equations, right? There's a 2 and a 4 and a 3 and a 6 and a 4 and an 8. How the hell are they the same? But if you look closer, you'll notice that there's a pattern, that this equation, let's call this equation 2, this is equation 1, this equation 2, let's do that. This equation 2 is exactly double of equation 1, and that's exactly how two different lines, well, the same line can appear to be different. Okay, this entire equation, both sides of the equation, was multiplied by 2 to give you a new looking equation, right? But if you break it down into the y equals to mx plus b format, you're going to end up with the exact same thing, right? So let's do it. For the first one, minus 3y is equal to 4 minus 2x, right? And then by convention we'll have the x first, so this is equal to minus 2x plus 4, right? And our next step is to get rid of our minus 3. So y is equal to minus 2 over minus 3x plus a 4 over negative 3. Okay, and negatives cancel out, and then this negative just goes over there. And for our next one, if we take minus 6y is equal to negative 4x plus 8, and then we take our negative 6 to the other side, we'll end up with a negative 4 over negative 6x plus an 8 over negative 6. And we have to simplify it, obviously, so 4 over 6, this is going to cancel out to a 2 over 3. The negatives are going to cancel out, and then this negative is going to go up there. And this is also not simplified. This is going to be a 4, and this will be a 3. So our final answer is going to be a 2 over 3x minus 4 over 3. And our final answer for this one is going to be y is equal to 2 over 3x minus 4 over 3. What do you know? They are exactly the same, right? The only thing is that here we had to simplify our numbers to get to 2 over 3, whereas this one was already in the simplified form. That's what I mean by two different lines that are the same, okay? And another term for the same meaning is coincident. Okay, so if you see two lines that are coincident, that means that they're basically the same line, that just appear to be different. Alright, so let's solve a linear system. The best way to solve a linear system, in my opinion, is by this method, which is called substitution. Substitution is hands down the easiest way for me to solve a linear system. I'm pretty biased. I'll show you both ways. There's also the elimination method, but if you have a choice between the two, I would say always go for substitution. Because in the vast majority of cases, that's going to be the fastest way to do it. So let's do it by example. Let's say you have a system of linear equations. Y is equal to 4x plus 3. And you have y is equal to a negative 3x plus 11. Now I know almost immediately just by looking at them that these two are going to intersect, because m1 is not equal to m2. 4 is not equal to negative 3. So I know that these are going to intersect, and it's going to have one solution. So what is that solution? We figure it out. At the point when you look at the graph of this equation, these two equations, you're going to see that they intersect at exactly one point. Meaning that this point is going to belong both on y1 and on y2. Meaning that the ordered pair x and y is a solution to both equations. So I take advantage of that by saying that y1 is equal to y2 at that specific point in time. And they're going to have the same x as well. That looks like a half. This is a y. Okay? So if I make my y1 is equal to y2, then I just substitute in their place with this term over here. Right? So y1 is equal to y2, therefore 4x plus 3 is equal to a negative 3x plus 11. And then I just simplify. Take the negative 3x to the other side, take the 3 to the other side. I'm going to end up with a 4x plus 3x is equal to a negative 3 plus 11. And 7x is equal to a 8. And x is equal to 8 over 7. I'm not done though, because I need to find the point, the ordered pair. I need to know what my y is. Luckily for me, because the x is the same and the y is the same, I can substitute this x into either equation and I'll find the correct y for that point. So in this case, I'm just going to plug it into y1. So I have my y1 is equal to 4 into, instead of x, I'm going to put in my substituted value, 8 over 7 plus 3. I'm going to end up with, this is 32 over 7 plus 3, and then let's do the same denominator. 3 times 7 is 21. So my y is equal to 53 over 7. Now, just to show you that you're going to get the same y regardless of which equation you put it into, I'm going to do it for y2 as well. So this is y1. So and y2 is equal to negative 3x plus 11. Negative 3, I'm going to substitute the 8 over 7 plus 11. Then I'll multiply this. This is negative 24 over 7 plus, let's say, over 7. This is 77. This is equal to negative 24, so this is a 3. And this is 7 minus 2, that's 5 over 7. And unsurprisingly, you are going to have the same y. So when they ask you what is the point of intersection of this linear system, I'm going to say it is the ordered pair 8 over 7, comma, 53 over 7. Now, let's look at another way of solving the system. I'm going to use the exact same one so you see that it works for both. Y is equal to, what was it? 4x plus 3. 4x plus 3. And y is equal to negative 3x plus 11. In elimination, what they try to do is, first of all, you have to do it in the same format. So if I had y minus 4x is equal to 3, then I should change this into the format y plus 3x is equal to 11. Okay, because it's necessary for the elimination purposes. When I manipulate an equation, I have to do whatever I do to this side of an equation, I have to do to the other side. And if I do that, then it doesn't matter what I do to one side, as long as it's done to the other, it will be an equivalent equation. Meaning, if I multiply if I multiply this side by 4, then I have to multiply this side by 4, right? So if I did that, now I'll say this is 4y plus 12x is equal to 44, okay? It's going to be equivalent. It's a multiple of this equation. It means the same thing. It just looks a little bit different. And this is important for me to solve by elimination. Because if I multiplied this one by 4 and I multiplied this entire equation, both sides, by 3, then I'm going to end up with this equation is correct, and then this one will be a 3y minus a 12x is equal to a 9. Now, if I look at these two and I add them together, okay? If I add them together, my 4y plus 3y is going to be a 7y. And my plus 12x, my minus 12x is going to be a 0x. Okay, so 0. and this is going to be 44 plus 9 is going to be 53. So 0 times x is going to be 0, so I just get rid of that. Then I am going to end up with the equation 7y is equal to a 53. Therefore, my y is equal to a 53 over 7. That's unsurprising, because if you look at the previous way we did it, well, first we found x, but then when we found y, it was 53 over 7. So we're halfway there. Now I have to find my x, and I'll do it the same way I did it for the other one, is by plugging in my y into either equation. So it could be this equation where you manipulated it with the 3's and 4's, or it could be the original equation. It really doesn't matter. I prefer to do everything into the original equation just because it hasn't been tampered with in any way. So let's take in this y here, and then I'll say, so for the first, so if I plug it into the first one, then it's going to be 53 over 7 is equal to a 4x plus 3. So isolate the x. 4x is equal to a 53 over 7 minus, get it into the same terms, this is going to be a 21 over 7. Then this is equal to a 32 over 7. Now 4x is equal to 32 over 7. Then if I divide by 4, then my x is going to equal a 32 over a 28. And then once this cancels out into everything, right, if you divide this by 4, this is going to be 8 over 7. That's going to be our final answer. Our ordered pair is going to be 8 over 7 over 53 over 7. And there you go. Those are the two systems. Take your pick. I know some people who prefer elimination methods, but to me, substitution seems to be the more logical way to do things, but it's entirely up to you. And you should know both ways for the curriculum. If you have any questions, please feel free to message me, and I'll try to answer your questions. If it's a big topic, or a lot of people are asking me that, then I may do another video trying to explain the subject better. Alright, thank you.